In first question, the half-life is given. We have to calculate the mean life. Also, we have to find the time in which the substance will reduce to 12.5% of its initial value. So here the half-life, that is T half, is given as 138.6 days. Now we have to calculate mean life, which is represented by this tau, which is equal to 1.44 into T half. We already have the value of T half. If we will multiply this with 1.44, then we will get our mean life, that is 199.58 days. Now we have to find the time after which the undecayed nuclei will left up to 125% of initial value. So we know that the undecayed nuclei n is equal to initial nuclei n naught into 1 by 2 raised to the power n, where this small n represent the number of half-life times. So now it is given that these undecayed nuclei remains 12.5% of original one. So we will put 12.5% of original nuclei, that is n naught, in the place of n, which is equal to n naught 1 by 2 raised to the power n. Now 125% means 125 upon 100. Of means into n naught. So here n naught will get cancelled out. We will remain with 12.5 upon 100. On removing this point, 10 will increase here. We will get 125 upon 1000. On solving this, we know that 125 into 8 is equal to 1000. So we get 1 upon 8 here. Now we get 1 upon 8 is equal to 1 by 2 raised to the power n. Now we know that if the terms are equal in an equation, then their power must also be same. So we can write this 1 upon 8 as 1 by 2 raised to the power 3, because 2 raised to the power 3 is equal to 8 and 1 raised to the power 3 is equal to 1. So on comparing these two quantities, as base are same, so their power must also be equal. So we get number of half-lives is equal to 3. So after 3 half-lives, our undecayed nuclei will be 12.5% of original one. From here we can calculate the time. We know that the number of half-lives n is equal to total time upon T half. From where we will get T, that is total time, is equal to number of half-lives into T half, where T half is the half-life period. So we get n here 3 and T half was already given as 138.6 days. On multiplying these two, we will get our answer. The time after which the undecayed nuclei will remain 125.5% of original is 415.8 days is the answer of this question. In question number 2, it is given that the undecayed nuclei remain 6.25% in 16 days, so we have to calculate the decay constant. It is given that the undecayed nuclei left 6.25% of original one. So on converting this percent into fraction value, we get 6.25 upon 100 into n naught. On removing this decimal point, we have to increase 0 in the denominator. So we get this. On solving this, we will get 1 by 16 of n naught. Now this 1 by 16 can be represented as 1 by 2 raised to the power 4, as 2 raised to the power 4 is equal to 16. On comparing this quantity with the standard equation, that is undecayed nuclei is equal to half raised to the power small n into n naught, we get the value of this small n, that is number of half-life, as 4. Now we know the relation n is equal to total time upon T half, from where we can say that T half is equal to total time upon number of half-lives, and the total time was given as 16 days and number of half-lives is 4. On solving this, we get T half as 4 days. So the half-life period of this element is of 4 days. Now we know that the decay constant lambda is equal to 0.693 upon T half. On putting the value of T half as 4 days, on solving this equation, we get 0.17325 day inverse as the value of decay constant. In question number 3rd, we have given that the half-life of the substance is 20 seconds. So we have to calculate decay constant, and also we have to calculate the time in which the substance will decay by 7/8 of its initial value. So T half, that is half-life period, is given as 20 seconds. So we know that the decay constant lambda is equal to 0.693 upon half-life period. On putting the value of T half, that is 20, on dividing this number, we get the answer as 0.0346 second inverse. So this is the value of decay constant lambda. Now moving to second part of this question. Now we know that undecayed nuclei is equal to initial nuclei into half raised to the power n. So it is given that the substance decay by 7/8. So the undecayed nuclei will be 1 minus 7/8 of original nuclei. So we get here n0 is cancelled by n0, and on solving this equation 8 will be the LCM, and here we will get 8 minus 7, which is equal to 1. So we get 1 by 8 is equal to 1 by 2 raised to the power n. This 1 by 8 can be written as 1 by 2 raised to the power 3. On comparing these two quantity, if the bases are same, then their power will also be same. So the number of half-lives is equal to 3. Now we can calculate the time. Now we know that the total time is equal to T half into number of half-lives, where T half is 20 seconds and number of half-lives is 3. So we get 60 seconds or 1 minute as the total time in which the sample will decay about 7/8 of its initial value.